Okay. And we will start adding people in. Hello and good morning, everyone. We will just wait for 2 more minutes and see if more people are joining, and then we will start by 10:02. Perfect. Good morning and welcome everyone to a joint webinar with the introduction of PMI-CP and in collaboration with SPAN-EA on sustainability. We are excited to listen to our panel of speakers that we have. Ricardo from PMI, we have Mike Taylor from SPAN-EA, we have Obada Al-Daladi, who's also coming in from SPAN-EA. So I'll pass on the floor to Obada to give a few words on what SPAN-EA is all about, and then we'll start off with our first land acknowledgement and then the presentation.
Thank you, Hamza. Good morning, everyone. Thank you for being here and thank you for making the time to attend this webinar. I'm here on behalf of SPAN. SPAN is a non-profit organization founded in 2014, and the main purpose of SPAN was to support and assist international professionals in navigating their licensing process and help them, whoever comes new to the country, to get their licensing either as an engineer or an architect. We have a board of 6 volunteers, and most of work is volunteer. And here we have with us Mike, who will be talking today about sustainability. And I think we'll start with the acknowledgement. So over to you, Mike.
Thanks, Hamza. So I'm just going to share my screen and we'll do a little land acknowledgement for us. So we recognize that we are situated on the traditional territories of the Mississaugas of the Credit First Nation, the Haudenosaunee Confederacy, and the Anishinaabe Nation, the Huron-Wendat, and the Métis Nation. We acknowledge and deeply respect how these communities have honored and sustained the land through generations, embodying practices that are regenerative, respectful, and harmonious with nature. We express our gratitude for the opportunity to share this land and pledge to pursue our endeavors in a manner that respects and reflects the principles learned from its original caretakers. So thank you to SPAN for acknowledging the land we're on today. We deeply value the lessons from the original inhabitants of these lands, and we're committed to integrating their sustainable and regenerative practices into our work, striving to honor their legacy in everything we do. And I think it's back to Obada.
Thank you. Thank you, Mike.
Okay. Thank you.
Again, I would like to thank Hamza and PMI for this opportunity to have this webinar in collaboration between PMI and SPAN. So thank you, Hamza. Thank you, Ricardo. And I will pass it to Ricardo.
Thank you very much. Good morning, all. Thank you for being here. It's Saturday morning, and I know you could be doing anything else. So I thank you for joining us to listen to a presentation on the latest certification from PMI, specifically for the construction industry, and some sustainability aspects as well. So just allow me to share my screen. Can you see my screen?
Yes.
Wonderful. So the construction industry represents one of the largest industries in the world. McKinsey and Company puts it at about 13% of global GDP. We also expect infrastructure investment, global infrastructure investment at about $70 trillion that's needed between now and 2035. Coupled with that, there's also a skilled labor shortage in the construction industry, with a really high percentage of the industry that will retire by 2031. So I think putting that all together, I think we're really in a great place in terms of the future for construction. And hence, PMI, with the feedback from the industry, has decided to invest in a certification that is tailored specifically to the construction industry. The industry can be described as having three main pillars: certainly process, technology, and people. We know that over the last little while, there's been tremendous investment in the process with new advances in like advanced work packaging, last planner system, lean construction principles that was borrowed from the Japanese manufacturing system and adopted and adapted here in the construction industry. Coupled with that, we have the latest technology in terms of AI, digital twins, blockchain, virtual and augmented reality, 3D printing, etc. We believe that there's not been enough investment in people, and hence, this is part of the sort of rationale for PMI investing in this area as well. So PMI teamed up with some of the biggest names in the construction industry. Some you'll recognize here: the U.S. Army Corps of Engineers, the U.S. Department of Energy, BHP, Saudi Aramco, Petronas, L&T from India, Jacobs. And we also teamed up with the Lean Construction Institute and the Construction Industry Institute. Some of the proprietary materials of these two are actually embedded in the course through a collaborative agreement with both of these institutes. Through this collaboration, we've launched 7 modules that are made up in the PMI-CP program and 2 certifications. This process started around November 2021 when we launched the first modules in the PMI-CP program. In about January to May 2022, we launched an additional 4 modules. And in August 2022, we launched the actual certification exam. So judging from that, we've been in the market now for about really a year and a half with the examination for the certification. In January 2024, we launched the ILT version of the PMI-CP. And in February 2024, we decided, based on feedback from our members, to launch it a 2-stage process where you have the PMI-CP and the PMI-SCP. And I will go into that in a little more detail in a while. So for the PMI-CP, you have 4 foundational courses and a capstone exam, very similar to the PMP, if you're familiar with it. In terms of the courses that are required, you have construction project communication, construction scope and change order management, construction interface management, and contract and risk management. We have 3 additional advanced courses that will award you the PMI-SCP, which is a senior designation. These are performance and materials management, technology and innovation, and execution planning. We also teamed up with Oracle Construction to launch the digital construction practitioner course late 2024, so late last year. And this is really geared to digitization of the construction industry data to certainly simplify much of the work that you do in the construction industry, giving you various tools available, particularly through Oracle's sort of range of offerings. The PMI-CP looks at 3 main areas: lean ways of working, data-driven approaches, and the use of the latest technology for construction. The key value behind the PMI-CP, certainly for individuals and businesses, is that it enhances project delivery, efficiency, quality, and risk in your construction projects, leading to more improved client satisfaction, providing you with a competitive advantage, and giving your organization growth in the process. Since its inception, we have more than 19,000 individual courses have been consumed, and we have significant adoption in the industry as well. In South Africa, for example, the South Africa Construction Industry Regulatory Authority, SACP-CMP, they've adopted the PMI-CP as the standard for the construction industry through, an independent evaluation of all the offerings in the market. And they're actually going to their parliament to make it mandatory for construction managers in the industry to have the PMI-CP as a requirement. We have adoption by the Zambia Engineering Institute. From Saudi Arabia, the Human Resources Development Fund recognizes the PMI-CP as one of the key certifications to empower the next generation of the workforce, and therefore will refund 100% for their citizens taking the PMI-CP. We also have the Saudi Contractors Authority that has adopted the PMI-CP for its members and will provide training for their workforce as well. In Bahrain, we have the Ministry of Works that has adopted the PMI-CP. And also, I'd be pleased to let you know that yesterday I was scouring job boards, and I saw about 10 jobs available on Indeed that list the PMI-CP as a preferred qualification. So we're seeing slow steps, but certainly in the right direction. And we're negotiating with a number of regulatory authority across the globe for adoption and incorporation of the PMI-CP into their construction regulation. Why choose PMI-CP? It enables organizations to upskill the workforce and utilize them in more high-value tasks. By equipping professionals with industry-specific skills, businesses can ensure, and you as individuals, of course, can ensure that your projects are completed on time, within budget, and to the highest quality standard, certainly fostering a culture of continuous improvement and professional excellence in your construction projects. The certification also helps to build trust with clients and demonstrating a commitment to excellence and adherence to the latest industry best practices. In terms of the requirement, you're required to have at least 3 years on-the-job experience within the last 10 years in construction projects or built environment projects. So anything around construction, certainly utilities, mining, anything that involves an aspect of construction will give you the required qualification in terms of experience. You also have to complete the 4 courses that I mentioned earlier, and these can be taken in any order and designed to meet your schedule. So we have a self-paced element or the e-learning aspect. It requires about 6 to 10 hours of committed time. And it also counts for PDUs or professional development units towards your certification renewal, as well as you can double dip with any other certification you have, like the PMP. The actual capstone exam is about 120 questions over 230 minutes. And it looks at contract management, stakeholder management, strategy and scope management, and project governance. 50% of the exam is focused on contract management. So hint, hint, you need to really focus in on contract and risk management module. We also have, as I mentioned, the instructor-led version of the course, which could be completed in a classroom setting with an instructor through one of our authorized training partners. This is about 2 days for each individual module of instructor time. Some instructors can actually get it down to about a week in total for all of the 4 modules, but it depends on the comfort level of the instructor with the material. The material can also be customized because it's a case-based delivery method. So depending on who the instructor is delivering to and which organization, some of that case may be adopted in the delivery of the material. And here we have a testimonial from Luigi Rosa. He says within the next 5 to 10 years, he anticipates that about 50% of construction professionals will hold the PMI-CP certification, and therefore will see a 50% decrease in projects that exceed their allocated budget or timeline or fail to deliver their expected benefits, which is a fantastic sort of endorsement. Here we'll go into a little detail in terms of what is covered in each of the individual courses. The presentation will be shared with you, so no need to worry about that. The first course, of course, I mentioned it could be done in any order, but certainly project communication. It looks at the importance of effective communication, how to develop and implement a communication strategy and plan, stakeholder management, active listening, formal communication, and project governance structure, using the big room or Obeya, which was adopted from the Japanese style, adopted by Toyota early, I think in the 1980s. Looks at commitment-based management, project management information system, and evidence-based communication tools. In terms of interface management, looks at intervention throughout the project lifecycle, attributes of good interface apology. Understanding the tools and processes and design and management for interfaces, how to effectively manage interfaces, and the capabilities needed for interface management. In terms of scope and change order management, business objectives and performance outcomes to drive scope, setting up the project for success with a clear scope to ensure all stakeholders are brought in, scope evaluation tool, scope governance structures, and putting in place an effective change order process, as well as the technology supporting scope and change order management. In terms of contract and risk, we go into the contract lifecycle, contract and delivery method strategy, risk classifications, risk management framework and process, risk management tools and techniques, and common causes of claims, and how to set up and work the claims and dispute process. In terms of the additional 3 courses, we talk about performance and materials management, setting up your performance strategy, project metrics, fostering the right culture, materials management, life cycles, strategy and plan, and operation and management of materials. In terms of technology and innovation, we look at technology in the built environment, what it is, why it matters, and where to introduce it in your projects. Establishing an innovative culture to drive better project outcome, methods necessary to support innovation, emergent trends, and the transformative potential of technology, certainly managing technology risk within your project, and how to bring technology into projects and when best to do it. The last course, execution planning, looks at advanced work packaging, introduction and components, the implementation model, as well as best practices and tools in advanced work packaging. Looks at setting up your LPS on projects, the principles and benefits, and planning for CCSU introduction. Here I'll pause and invite you to join the PMI construction community on LinkedIn and be part of the sharing of content on the community if you're not yet a member. I'll pass it back to Almadi.
Perfect. Thank you so much, Ricardo, for that presentation. And I hope the audience benefited from understanding and learning more about the buzzword that PMI-CP is creating all over the world. And you're right, even my LinkedIn is filled with PMI-CP related information, and the new ambassadors being launched in different parts of the world. There is more course content that is being shared, and a lot of positive outcome in terms of the knowledge that is being gained from this course, which is benefiting, and hopefully, just like the vision that was shared earlier, more construction professionals benefit from this program and bring that impact to their bring that positive impact to the projects they are working on. We'll now pass to Obada, if you're around, and do a quick introduction to what Mike Taylor will be speaking about.
Thank you, Hamza. Thank you, Ricardo. I think just to circle back on Ricardo's presentation, I really think, well, thank you, Ricardo, for this presentation. I think we really need this initiative from PMI where we can sharpen the skills in delivering more efficient projects on time and on budget. I think this is the most challenging thing that we have in our daily or in our construction life, where always struggle to bring back projects to schedule and to budget. And I hope this PMI, CP, and SCP will be a tool to help individuals to navigate projects in a more efficient way and bring back projects on track and on budget. Going to Mike Taylor here. I had the pleasure to chat with Mike a little bit yesterday, and I was honestly amazed with his experience and his background. Mike comes with the background in architectural and some construction experience as well, and he's tried to implement sustainability and designing high performance building and high performance construction skills. And I think he will have his partner Brian with him to present today. So again, thank you, Mark, for making the time for this presentation, and we're happy to have you here, and the floor is yours.
Thanks, Obada. So I'm just going to quickly see if I could share my screen. I realized maybe I didn't share it before, so let's make sure we got it going. You guys see my screen?
Yes.
Perfect. So Brienne's not here quite yet. So my partner Bree is she should join us shortly, but we'll see if we get her on. So I'm hoping that she comes. But in the meantime, I'm gonna start, and then if she does show up, hopefully I see something. If you happen to notice that she's raised her hand, Obada, give me a thumbs up, and I'll stop talking. I have a bad habit of continuing on. So
I'll do my best.
wonderful. Thank you, Obada. So wonderful to be here, everybody. Thank you for giving me the time and the space to talk about sustainability. So, as Obada said, my name is Mike Taylor. I'm a professor of architecture and sustainability at Humber College, the North Campus, in the Faculty of Applied Science and Technology, and I've been doing things in architecture for about 15 years. So I make up one half. My other partner here is Brienne, one half of a new consultancy, a sustainability consultancy here in Toronto that we've named Heavy Climate Consulting. So co-founded by myself and my wonderful co-host when she gets here, Brienne Belitsky. We bring together expertise in architecture, building science, decarbonization to tackle one of the biggest challenges in the built environment, and that currently is carbon emissions, at least in our opinion. So our mission is to help create buildings that actively undo the impacts of human-caused climate change, and we are dedicated to helping project managers, architects, developers, and organizations like yourselves to take the lead on crafting buildings towards a zero carbon future. So if you get a chance, check us out, heavyclimate.ca. And I think just tying into Ricardo a little bit, I want to make sure that we kind of tie PMI-CP. So really, my experience coming from the built environment in architecture, watching things kind of transpire from the built environment side of things, sustainability can be a core principle of a client, right? So it could be a core principle of a client working in the built environment. And as project managers, it's crucial to understand what, how, and when sustainability goals can influence the trajectory of a project. So sustainable construction methodologies can help to de-risk the future influence of climate-related events, imagining, really hot summers, really cold winters. We can use architecture and kind of policies to ensure as project managers how to get really resilient buildings. And not to mention all of these things help to provide buildings that are better for the people who live and work in them, leading to better client satisfaction. So first thing we're going to do is just introduce carbon literacy. This is a little bit of a departure. So I think that we're going to talk about carbon literacy today, and that is really just, maybe it's a refresher for us, maybe it's brand new. Either way, we're going to talk about it. And it's referring to the knowledge and understanding of how carbon dioxide has a role in climate change and how individuals, organizations like you and yours can reduce the impact of that carbon. So as building professionals, it's extremely important that we understand the impact of carbon because it represents 40% of worldwide carbon emissions. 40% of our carbon emissions come from buildings. So this is according to the United Nations Environment Program. That all being said, today we're here to offer a refresher about what carbon is, the challenges that it presents, and how we can use buildings to serve and heal the planet. So a little bit of a agenda for today. So first, we're going to do a little introduction to carbon and climate change. Then we're going to step into some climate legislation. So I should say that we're going to start at a high level, kind of global parameters, global ideas and targets, and then we're going to step down into national targets in Canada and even further down into Toronto specific. So if you're coming from other parts of the world, I know we have some people I know calling in from, I heard the Philippines and I had heard China today. So everybody's got different climate legislation. We are today focusing a little bit more, I'm going to say locally in Toronto for me, locally, but making sure we're trying to include everything. Then we'll step into some key carbon concepts. This is vocabulary related to carbon and its place in the built environment. And then how can we prepare for a low carbon future? So that would be the last thing we're going to get to. How do you apply some of the low carbon ideologies in terms of project management, we might say? So what are some ideas that we can use from that project management perspective to get to low carbon buildings? So we've done this. So I just want to say thank you again for SPAN, acknowledging the land we're on today. So thank you for that, everybody on the call. And so the first part here, we're going to start with the basics of carbon. So what is carbon, right? I think we hear about it all the time, but what is it? What is it really? So when we talk about carbon, it's fundamental element. It's essential to life. But when we talk about climate change, we're usually referring to carbon dioxide. So carbon dioxide itself is a colorless, odorless gas that's released when we burn fossil fuels like coal, oil, gas. It can also be produced through natural processes like respiration. So what are we worried about? So we're worried about the extra CO2 that comes from human activities, driving cars, generating electricity, manufacturing stuff, right? The stuff that comes from Amazon, the stuff that comes from all over the world to our doorstep. And that's really what's driving global warming today. So a couple things here. So understanding greenhouse gases. So CO2 isn't the only greenhouse gas, but it is one of the main, what's called anthropogenic ones. This means it's caused by us, it's caused by humans, and it's responsible for a significant portion of global warming. So other greenhouse gases are methane, CH4, nitrous oxide, N2O, refrigerants, right? So things in our air conditioners, and water vapor. So these gases are kind of like a blanket that wraps around the earth and they absorb and trap heat inside the atmosphere, which, I'm sure since 2007, we remember the greenhouse effect from the fabulous Al Gore on Inconvenient Truth, right? So still here, hasn't really gone away yet, right? So we're trying to get to that. So the role of carbon in climate change isn't just causing the climate to become hotter. So trapping carbon in the atmosphere is actually causing things like polar ice to melt, sea levels to rise, ecosystems get impacted, leading to an increase in the frequency of, we see wildfires, other climatic events. And you don't need me to tell you that this is not just about natural environments, but it also affects almost the risk profile, the socio-economic structures of human society. And I don't want to, make this a catastrophic thing, but it is really important to address. Next thing, so we've got global warming potential. So you see that little GWP. So this is really a kind of common language for us to discuss how CO2 works. And we use it as a kind of equalizer between how we speak to different types of products, materials. Global warming potential is meant as the equalizer across different products. So methane, for example, CO2 has a GWP of 1. So carbon dioxide has a baseline global warming potential of 1. And why this is important is that we can then compare it to something like methane. We burp, we have, cows in the field, we have, things that are giving off methane. It is 25 times more potent. So it has a GWP of 25, meaning it traps 25 times more than CO2 over the same 100-year period. Nitrous oxide, make your car go really fast, has other uses, but has a GWP of 298. So almost 300 times more potent than carbon dioxide. So when we talk about refrigerants, another thing that I think we all like to be cool in the summertime, or if it's really hot, we like to cool down. R410A, so R410A, a common refrigerant, is 2,100 times more potent. The official number is 20 2,088 times, but if you're really interested. So 2,100 times more potent than carbon dioxide. So for every molecule of carbon dioxide, one molecule of that 410A, R410A, excuse me, is 2,000 times more potent. So in your work, if you're looking or reading about how to reduce carbon, you'll oftentimes see this little E next to the CO2. And again, that's to simplify things. So we convert all of those gases into carbon dioxide equivalents. So for instance, if we come back to the comparison, 1 ton of methane is equal to 25 tons of carbon dioxide. So this lets us compare all greenhouse gases in a singular way and compare them effectively. So it's important to understand that climate change isn't just a natural process. The distinction between natural climate fluctuations and the changes that we, human-induced or anthropogenic climate changes, is crucial to understand the difference. Excuse me. So human activities, especially burning of fossil fuels, have greatly increased the concentration of greenhouse gases in our atmosphere. And this has, of course, accelerated global warming. So starting at a kind of global scale, so this is all the way back, so all the way out, we're trying to get a big picture of how and what carbon legislation looks like today. So we're going to start big, we're going to get smaller. So hopefully we've seen these, but this is in 2015, the United Nations set forward the United Nations Sustainable Development Goals. So 2015, 10 years ago, 17 global goals to address urgent challenges facing our world. Things like poverty, inequality, climate change, environmental degradation, just a blueprint. So it's a blueprint. How are we going to make a more sustainable, equitable, and prosperous future for everyone by 2030? So the goal here is 2030. That's 5 years away. Great. So every one of these 17 goals, if you're not familiar, check them out. It's free to kind of check out and download. However, despite this call to action, progress has been, we'll call it slower than what's needed, and we're not really on track to meet these targets. So just getting a little closer to home here. So this is Canada. This is Canada. There's a lot of information in this chart, but really the key takeaway from this is called the Climate Action Tracker is that you can see at the top here that Canada, unfortunately, is insufficient. So we're insufficient with when it comes to where we're tracking. Canada is lagging behind other nations, right? So Canada's behind. We are, of course, a big oil and gas supplier, so we need to be careful with things like that. We also build a lot of buildings. Anyways, there's a lot of things we can talk about here. The Environment Commissioner warned us we cannot afford a fourth decade on a failure on climate action. So Canada's overall rating has improved to insufficient from critically insufficient, right? So we're now insufficient, getting better and better and better, but this is mainly due to advancements in policies and actions, but further measures beyond the kind of current climate plan are required to reach a sufficient rating. So some might see this as a failure of policymakers, but maybe, we can look at this as an opportunity to see what must be done in the sustainability space. It can only strengthen the argument towards high performance, zero carbon buildings. I'm going to check in and see if Brianne has joined us, but if not, I'm just going to continue. So Brianne, are you there? Maybe not. Okay, that's okay. We'll keep going. So Canada's been experiencing more frequent and more severe climate-related disasters. We had our record-breaking wildfires, the worst kind of records to break in 2023. Extreme flooding in Toronto in 2018, 2020, and now in 2024. And then, of course, Hurricane Fiona, pretty horrific events. So these events underscore the kind of urgency about climate change. So what in Canada are we doing about it? So Canada, has set ambitious climate targets. By 2030, we want to reduce our greenhouse gas emissions 40 to 45% below our 2005 levels. So by 2050, Canada wants to be net zero emissions, meaning any remaining emissions will need to be offset. So these commitments aren't just about meeting internal obligations, they're about protecting our communities and our future. This is the chart. Pretty steep decline in emissions, right? So on the left, we've got the national greenhouse gas emissions in metric tons of CO2 equivalent. And then across the bottom, we've got time. Pretty aggressive targets. So these goals, ambitious as they are going to have a significant focus on the built environment. So I know we're talking about PMI-CP, we're thinking about buildings, we're thinking about, the spaces that we need to create for people to work and live in. They are a major source of carbon dioxide emissions. So here, the green line shows us our historical emissions from 1990. So green, blue, depending on, I'm pretty colorblind, so green or blue, historical emissions from 1990. And the gray line, the one that kind of trends downward, is a huge reduction. So this is a huge reduction to get to net zero by 2050. 25 years to get us there. So the Canadian Net Zero Emissions Accountability Act, long to say, the short form is the CNZEAA. It's a government piece of legislation that was developed to get us there. So for our buildings, this means adopting stricter energy efficiency standards, using more sustainable materials, and implementing low carbon construction strategies. So innovation, big part of this. Later on in this presentation, we'll get into a little bit more detail about construction and the things that we can do. But these efforts are really crucial for reducing emissions and building resilient, sustainable urban spaces and aligning with our Canadian national environmental objectives and overall, or even our global commitments. So hopefully you've seen this, but if you haven't, happy to introduce it. So we've got alongside Canada's national goals, we also have provincial and then also municipal legislation. So now we're all the way down into TGS. This is really the core of some of the work that I've been part of in Toronto is looking at Toronto green standards. So Toronto, for example, we lead with the Toronto Green Standard. Here we set sustainability guidelines for new buildings to enhance energy efficiency and lower greenhouse gas emissions. Similar initiatives are happening across Canada. So newer ones, I actually was just at a talk a couple weeks ago. I hadn't heard of it until that talk, and I'm sure it existed. It's just things are new and innovative, and we need to be on top of them, especially for project managers. We want to know the things that are happening in the industry because, as a good friend of mine said, if you know what the future holds, then you can make a lot of money, right? So we want to make a lot of money. We also want to make sure that we are being as expert as possible about the things that exist in that municipal space, in the kind of code space, and be really good at understanding your client's needs, but also what the kind of overall authorities having jurisdiction look like and what some of these systems in place are to get to better buildings. So the newest one, like I said, BEPS. So we got Building Emissions Performance Standard. And this strategy it mandates specific emissions targets that help to decrease overall energy use and reduce the impact on the built environment. So details on BEPS, it's more fun to say BEPS than Building Emissions Performance Standard. The compliance timelines and the support programs are going to come out this year. So 2025, it's starting. So BEPS, so keep an eye on that if you're working in Toronto. You can see that Brienne has just joined us. Good morning, Brienne. So Brian's just joined us. So I'm just talking about TGS here. So as project managers in the building industries, we all have a role. Hey Brian, you have a role in understanding the regulatory requirements to ensure compliance across projects. So some key concepts. So I know I've said a lot already, but I'm going to keep talking. So, to start us off, I've got, it's important to kind of know and understand some key vocabulary. I know we've already done carbon dioxide equivalent. We did global warming potential, but now we're going to go further. We've got some other vocabulary here. So first is the carbon footprint. I remember calculating my carbon footprint. You take a plane ride. If you happen to eat meat, there's all these things that can impact our carbon footprint. And really, this is the total amount of greenhouse gas emissions caused by our actions. So both directly and indirectly. And it's expressed in terms of that CO2e or carbon dioxide equivalent. So it includes not just the emissions we generate by living in a building or driving our cars or mowing the lawn. It's also about the carbon impact of manufacturing, transporting, and creating the products we use in our everyday. So we mentioned that Canada has to have net zero emissions by 2050. So what does that mean? So as a quick refresher, net zero carbon is about balancing the amount of carbon dioxide emitted into the atmosphere with an equivalent removed. So the result is no net increase in atmospheric CO2 levels, so net zero. We're going to hear more about how this is possible, but at a high level, if you hear somebody talking about net zero carbon, that's what they're talking about. So hopefully, second item here, we got decarbonization. Hopefully you've heard about this, but decarbonization is the process of reducing or eliminating carbon dioxide from human activities. So a big part of it is transitioning away from fossil fuels, moving towards renewable energy sources, increasing energy efficiencies, implementing strategies that capture or offset carbon dioxide. Carbon sequestration, this is about the natural process of how we're actually going to take carbon dioxide from the atmosphere and we can put it away. We can put it away in things like forests, soils, the ocean. And while it's natural, we can encourage it. We can encourage it through practices like planting trees, reforestation, so soil management and conservation. And this can help to offset those emissions we can't fully eliminate. And the last piece here is, two last pieces. The other piece of this is carbon storage. So, when we talk about carbon sequestration, that is a natural process. So carbon storage is actually when we're going to take that carbon and put it into our buildings. And again, I hope we've heard of this before, but it's essentially looking at how we can make buildings little or big carbon sinks, a sort of anthropogenic version of carbon sequestration. So we're kind of man-made processes to get carbon into built buildings, built structures, and reduce the overall carbon. Next up, so scopes. So scope, I know when we talk about scope, we think about, big projects. What's the scope of the project manager? What's the scope of the project? What's the scope of, what are we doing? So this is a little bit different. So this has to do with scopes of emission. So these represent different layers of responsibility when it comes to carbon emissions. So scope 1 emissions are direct emissions from sources owned or controlled by a company. So if you're burning fuel directly at the site that you're on. Scope 2 emissions are indirect emissions from the generation of purchased electricity, steam, heating, or cooling used by a company. So Ontario happens to have pretty good electricity emissions by chance. And then scope 3 are the emissions. It's the broadest category. And this covers all other indirect emissions that come in terms of a company's value chain. So those are things like that come from a supplier or product use. And so with that, I'm actually going to hand it over to Brianne. And Brianne, welcome to the chat. So I'd like to introduce my partner. So Brianne Belitsky here. So Brianne, if you want to take over, I'll turn off my mic.
Absolutely. Thank you so much, Mike. Okay, so now that we've talked about carbon in general, let's talk a little bit more specifically about carbon in the built environment and the role that it plays in the built environment. So you can advance to the next slide, please, Mike. So why should we, as building professionals, be so concerned with the carbon emissions in our work? Quite simply, the building sector is a massive contributor to global carbon emissions. So on the left, you can see globally, buildings account for nearly 40% of the CO2 emissions. It's those two pie pieces there in yellow. We've got the operational carbon and the embodied carbon, which we're going to talk about a little bit more. But in general, we've got that whole 40%. Perfect in yellow. In Canada, buildings contribute 17% to our national emissions, but in larger cities like Toronto, they're responsible for a whopping 56% of our total emissions. So that means that buildings, both in their construction and in their everyday use, are a critical piece of the climate puzzle that we're here to talk about. So next slide, please. Perfect. So there's two types of carbon emissions in buildings. We've got our operational carbon and we've got our embodied carbon. So in this graph that you're looking at here, the operational carbon is in blue and the operational carbon is in yellow. And I'm going to explain both of those for you right now. So operational carbon are the emissions created when we operate our building, right? When we heat them, when we cool them, when we work inside of them. So think about all the energy needed to keep a building comfortable, functional, and lit. These are the operational carbon emissions. In 2022, the building sector accounted for 34% of the world's power consumption. So we use a lot of power in our buildings. I'm sure that doesn't surprise anyone. Operating a building creates a ton of emissions, especially when that energy is sourced from fossil fuels like coal and natural gas. These release carbon dioxide when they're burned. On the other hand, there's something called embodied carbon. So while operational carbon has received a lot of attention over the years, embodied carbon has more recently been recognized as impactful. And, as you can see in this graph, very impactful. There's a lot of times when embodied carbon is released. So embodied carbon refers to the emissions associated with the materials, the stuff that we use to build, from extraction to processing to transportation and installation. All of these materials have embodied carbon, but materials common in the built environment, like steel, cement, glass, aluminum, require a lot of energy to make and to transport, to install, to repair, and these represent significant carbon dioxide emissions. So historically, we've been focusing on reducing operational carbon, like improving insulation, upgrading HVAC systems, using renewable energy. We've made really great progress. Today's buildings are far more energy efficient than the buildings that were built in the past. But studies show that embodied carbon, the emissions tied to the materials and the construction processes, as we were describing, can account for between 30 and 70% of a building's total life cycle emissions. So said another way, as buildings become more energy efficient and energy systems are electrified, embodied carbon will make up an even larger share, making it essential to address this right now. So let's talk about some strategies for reducing carbon emissions in the buildings. So earlier we mentioned we're going to hit Canada's net zero goals with a combination of stricter energy efficiency strategies, using more sustainable materials, and implementing innovative construction strategies. Let's dig into that a little bit more. So in terms of operational on the left, like energy efficiency, I think most of you are already familiar with the tools we need to reduce energy demands in buildings. I'm sure many of you have been involved with the projects that use energy efficient systems, equipments, energy efficient appliances, incorporate passive design strategies, or maybe even renewable energy sources, which have been helping us shift away from fossil fuels. And as Mike mentioned, we've made really great strides in this area. As we reduce the impact of operational carbon, though, the relative impact of embodied carbon grows. So how do we go about reducing embodied carbon? Let's look at 3 key strategies to help reduce embodied carbon in your projects. So the first is to build less. So by choosing to retain existing buildings or reusing existing materials, we avoid more extraction and production of new materials. Second, we can think about designing differently or shifting towards regenerative and bio-based materials as much as possible. Regenerative materials are materials that respect the earth and the people on it by having less negative impact and maybe even sequestering carbon within their structures. Lastly, let's choose better. So recent innovations are improving the carbon footprint of conventional materials. Low carbon concrete has a higher SCM percentage, so secondary cementitious material. By using more SCMs, we use less Portland cement, which is really high emissions. We can also utilize steel made from recycled content or produced with less emissive technology like electric arc furnaces. Or we should be ensuring specifying wood from sustainable managed forests. These choices help ensure our buildings honor and safeguard the planet. The urgency of designing lower carbon buildings really cannot be overstated, because if you think about it, half the buildings that are going to exist in 2050 haven't even been built yet. So the choices we make today will shape our carbon impact for decades to come. To truly address climate change, we have to prioritize near zero emission resilient buildings. Right now, this is our opportunity to reshape communities one building at a time. There are numerous strategies to achieve this, and at Heavy, we're passionate about exploring every possible avenue to minimize carbon emissions. Our purpose here is to help equip professionals, designers, project managers, everyone, companies with the tools and knowledge to integrate these low carbon strategies into their projects effectively. So lastly, let's just talk a little bit about preparing for the future. Here are some ideas you can consider in order to improve your projects today. So first, let's start with some circular considerations. The first question we should be asking is, does a new building even need to be built? Can an existing structure be adapted or reused? If constructing new is really the only option, consider ways to reuse existing materials from that site or from other projects. Next, let's think about the site selection. If building new, choose brownfield or infield sites over greenfield locations in order to preserve valuable green space and ecological functions. I know this isn't always up to us, but it's something that we should be thinking about, we should be considering, like if it's all within our ability to have impact over this decision, we shouldn't be paving over green when brown and existing sites exist. Next, let's think about optimizing material choices. So when procuring materials, let's prioritize low carbon options like recycled steel, sustainably sourced timber, low carbon concrete, or ideally bio-based materials. Use environmental product declarations, which are EPDs, to understand and minimize the embodied carbon impact of your selections. Next, we can design for adaptability and reuse. Consider the entire life cycle of your building. How can it be adapted in the future or disassembled to reuse its components? One of the first ones we mentioned here was start with circular considerations, like can we reuse existing materials? Well, if we design for adaptability and reuse, that means in the future, someone will more likely be able to reuse those materials. This mindset can help reduce future waste and maximize a building's value over time. Next, we can incorporate passive design strategies and energy efficiency. So once you've addressed circularity, material choices, use passive design strategies to reduce energy needs. Optimize building orientation, insulation, natural light, and ventilation to minimize operational carbon. And then lastly, we can think about embracing renewable energy. Now, it's not that this is the least important, but this is just something that comes later on in the process. After reducing the building's energy demand as much as possible, we can explore incorporating on-site renewable energy sources like solar panels or wind turbines in order to help further reduce operational carbon. So not only do these strategies help to reduce carbon emissions, but they also future-proof your projects against evolving building standards and client expectations. By approaching sustainability from this holistic life cycle perspective, you'll create buildings that are genuinely future-proof and climate positive. So as regulations evolve, which we know they're doing, and new technologies emerge, which obviously they are, continuous learning and adaptation are key, which is what you're doing here now. So that's awesome. Stay informed about the latest green building practices, monitor updates to building codes, and keep exploring innovative solutions to ensure your projects not only meet, but exceed future sustainability standards. And I'm going to pass it back off to Mike to wrap us up.
Yeah, so the last thing here, thank you, Brand. So the last thing here, we just wanted to make sure everybody knows. So if there's anything that you guys thought was interesting, we're committed to helping project managers, clients, developers, and organizations lead the way in creating zero carbon futures. So we want to help to design buildings that actively work to undo the impacts of human-caused climate change. So whether or not you're looking for deeper insights into circular strategies, maybe you want to explore some passive design or low carbon techniques, maybe you want to learn which bio-based materials you can use in your projects. We're here to help. So if there's any way that we can help, please don't hesitate to reach out to us. And remember, it's heavyclimate.ca. So thank you so much, Obada and SPAN, for letting us kind of hang out and discuss a little bit of our ideas with you today. And with that, I should hand it back to Obada or Hamza.
I'll take it on from here.
Thank you, Hamza.
Thank you so much. That was a very detailed presentation, and I'm sure it brought in a lot of strong knowledge and understanding of the challenges we're still continuing to face even in 2025 on sustainability. I mean, I see it every day in ongoing construction projects that I'm managing, especially with the transportation emissions and the abuse of sustainable practices and not properly implementing them. And unfortunately, it has to do a lot with not having the amount of knowledge that is required. And I think these kind of sessions really help. You can hear the baby in the background, so I apologize for that. But
Is that Obada? Is that you, Hamza?
That's mine. But Obada also has a small baby that has just come to a very beautiful baby, by the way.
Thank you, Hamza. Hamza had this baby ahead of me like 7 months ago, right? Was it 7, 8?
Yes. She's
Congrats to you
walking and
both.
crawling now, and unfortunately, it's very hard to keep up with her. She's But okay, we'll get back to. So we have some good questions here, and I thought we'll just jump into them if that's okay. And if you have more questions, you can always ask them in the chat box, and I'll bring it to the attention. So we'll start with Philippe Chow's question on net zero carbon monoxide. Why do people talk about net zero and not net negative? And the latter would mean that we try to remove more carbon monoxide than we create. Would Mike and Brienne like to?
Sure. Yeah. So, I think it's interesting just to imagine, conversations with people about getting to operationally net zero carbon just in our operations was really challenging. And we're almost, I would say we can get there now. And then now we're looking at net zero embodied carbon. So the amount of carbon that it takes to build buildings, how do we get that to zero, right? To go even further, those regenerative buildings to go, net positive buildings or net negative buildings, depending on which descriptor you're using. I would argue that it's a function of, cost. How much further can we take things? And we're kind of here, and that is certainly the next step. And I open it up to Brienne as well if she's got comments on net positive buildings. So
I mean, I think what you said was great, Mike. Yeah, I mean, net positive buildings would be fantastic, but it's always going to be a little hard, especially in terms of materials, in terms of carbon, to have something be net positive, because there's always going to be an impact of creating materials. In terms of operational carbon, it's a little bit different. We can technically, there can be a way where we're creating more energy than we're using. Absolutely, that's possible. There's schemes where the energy companies will actually buy the extra energy off you. So net positive in terms of operational carbon is totally possible. But in terms of embodied carbon, that's never quite going to be possible because there's always an impact to creating materials. What we can do is hope to reduce that impact of those materials as much as possible. With some of those strategies, reusing things that already exist, using low carbon materials when we can, using materials that do sequester carbon. But I don't think there's really any way for that to ever be not impactful in some way. Our best bet is to just minimize our impact as much as we can.
Thank you. There's another question which is on concrete. It says concrete plays a vital role in construction, but most of the low carbon alternatives are often costlier. Are there any cost-effective methods for reducing concrete's carbon footprints?
Yeah, I mean,
Brienne?
I can kick off on that, but then I'll hand it back to you because I think Mike's got a bit more of a design background. But one of the first things is to design differently. If we think about our buildings and our designs, some of the things that use a lot of concrete are things like transfer slabs, right? So if a design is done in a way to minimize the need for a transfer slab, then we don't need these huge, thick layers of concrete. We can do things like bubble decks or other sort of design strategies that mean we need to use less cement. And of course, I'm not the kind of person that's going to tell you you should never use cement. Cement is useful and we need it in certain situations. I think we just need to focus on what the best use of each material is. We're going to need to continue to use concrete below grade. It's the best material for that, but we don't need to be building above grade structures out of concrete or not all of our above grade structures out of concrete. There are other materials that we can be using for that. So I would say design plays a really big role. And if we design differently, then we don't need as much concrete. There's also a lot of times where we're designing with concrete to dry at a certain rate with a certain amount of inputs, with a certain amount of SCMs or certain pressures that perhaps we don't always need. Some things we do need to dry and cure as quick as possible so the next step of construction can go on. But there are other instances where we don't need such high strength or we don't need it to cure quite so fast. So just being a little bit more mindful in the design. Well, does this need to dry within 28 days, or is that not as necessary for this part of the building? And it could have a lower Portland cement content so that it spends a little bit more time curing, but has less impact overall. Do you have anything to add to that, Mike?
Awesome. So the big thing that you said was design. So I actually think that design is a huge part of this. So, I know we're talking to PMI, PMP, PMI, LOC as well, right? So I think that when we're looking to design experts, I actually think even from a project management perspective, if you're educated about this stuff, you can kind of inform your client, hey, what if we, do these things as it relates to design? You have a designer that maybe isn't implementing simple things like, if there's any engineers on the call, like load paths, right? So as Brianne said about transfer slabs, do you have to have a transfer slab? More recently in Toronto, there's things like, parking, underground parking is not always required, and that can be a significant carbon cost, we might call it. Uh, and then the second thing is having worked on projects in Montreal, say for instance, um, when it comes to the drying time, the curing time, excuse me, of concrete, there's different things that we can do. The first, of course, is going to be really good structural engineers can design really slim slabs, right? So, what is the load? How do we get that all the way as slim as possible? And then the second piece is any of those mass slabs, exactly as Brian said, 28 days, does it need to be that long? If you can extend your schedule, and I know thinking about it from the project management lens, extending the schedule isn't always something that's, useful. So if we're talking about, a condo project, you're stacking, you got your fly form, blam, 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 you're going all the way up. Um, it's pretty quick. So I don't know if I have an answer for a condominium, but certainly for large scale institutional projects, it's going to be things like extending cure times. And then that SCM, definitely a huge part of it. So how do we get supplemental cementitious materials into our specs? Well, that could, again, back to a design question, is working with maybe a supplier as well as the structural engineer to understand, what can we get into that concrete. And then the last thing is Division One specifications. So if I just say one last thing, is working on these large scale institutional projects inside of your Division One specification, you can actually start the process by setting targets. So even just having a benchmark to understand where you land on your embodied carbon on a project can be helpful to discuss with your client if that's one of their goals in their RFP, to say we want to have a zero carbon building. Suddenly, maybe you have to come up with some other design based, evidence-based ideas around lower carbon buildings, and you just don't jump to what's business as usual, which is concrete. So, you have to start exploring other ideas that aren't just concrete. So back to Hamza or
Okay.
anybody else. Sorry.
Thank you so much for that response. I'll get another question in, and then Manoj, I'll get you to unmute yourself since your hand is up. And this is more, I think, it's a very blended question for Ricardo. Maybe Ricardo, you can chime in. And it is, how can training such as PMI-CP help project managers integrate carbon footprint reduction into planning and execution aspects of construction? It's a loaded question as well.
Yeah, it's a fantastic question, and I think it goes more to Mike and Brianne than us. We, within the PMI-CP module, while we touch on sustainability, it's not a main focus. So I'd really lean on Mike and Brianne to really, help us understand how this could be built in more to the planning and execution of projects.
For sure, if I could add, it's back to the idea of benchmarking. If we're thinking about how to de-risk projects, which I know the risk profile of some of these ideas, it changes, right? So if somebody says to you, I want a net zero carbon building, it changes the risk profile. It's, becoming more common, but I would argue it's not the standard. Certainly it's it's easier to build an 80-story condo out of concrete than it would be out of mass timber, right? So, I think that if the question is how do we help, it's really about course creation, education, educating yourself, what systems are out there. I think that there are universities and colleges, Humber included, that are looking to sustainability as an integral part of the classroom. So, I start a class on adaptive reuse of existing buildings, for instance. So it's going to start at, with my students, and then your students, and then, everybody's students kind of coming up with some knowledge of how this is going to work. But I think from a project management perspective, it's good to set those targets early because they do influence the overall trajectory of the project. So, Brianne, I don't know if you want to chime in on anything else. I'm probably talking too much.
No, I think what you said is bang on. Yeah.
Thank you so much. Manoj, I'll unmute you now in case you have something to add on before we'll move on.
Hi everyone. So as I said, back in India, I used to do some paper. Like I was helping my professor with the same kind of project, and I'm coming from a structural engineering background as well. So I have designed two three buildings which were using LEED certification, and like say for instance, we used lightweight concrete, and specifically in beams where the tension is in there, we reduced the concrete density, and even in the slabs we introduced clay pots which would act as fillers and reduce. But out of even back in India, fly ash is much more easily available. So the issue what we faced over there is because up to 20% is more usable. When the percentage hits 50%, workability is totally hard. Like India is much more warmer in temperature. So whereas in Canada, I don't see it. The settling time, even if we add more admixtures, the settling time won't be workable. So is there any other better ways where they are doing right now to handle the concrete? Because from my observation, 30 to 40% of the building carbons are from concrete itself, but there aren't much ways reduce it as far as I know. So is there any other alternatives available at the market right now?
So great questions. So I don't know, Hamza, or is there anybody else? Sorry, I realize I'm doing too much talking, maybe, before I get started here. So Manoj, having worked on a project, again, back to Montreal, um, they, I was basically told from the structural engineers that the concrete cement supplier are actually the ones who are driving such a huge part of this, and I imagine cement is being made, all over the world. Lafarge happens to be a big producer of cement. And while I don't advocate to use cement or concrete first, it definitely has its place in construction, right? So there's something called EcoPact concrete, if you've heard of it. EcoPact Max, I think, was the one that we looked at. And it is they say it's 70 to 90% reduction. So EcoPact Max, I'm not I have no interest in representing Lafarge. It's just information from their website. It was one of the products that we did look at. And as you said, the curing time was a huge challenge with this product. And, we weren't as worried because we've got mass slabs and, concrete masses. So it has its uses. What I would suggest is look to other materials before concrete. So, in our one slide there, we're thinking about materials as a kind of one of the first steps that you can do, and part of a process is to say, most people would say just build it out of concrete, and I would say, do we have to build it out of concrete? Are there some other options we might look at, even what has a lower carbon footprint, right? So again, back to the idea of people just jumping on concrete first, because it is super common, right? So we use it all the time. It has a huge carbon impact. But Manoj, check out Lafarge EcoPact Max and see if it has any. I'm not a structural engineer, I'm an architect, so very different experiences for me to you. So check it out if you're interested.
Yeah, as you said, 70 to 80% reduction means it would be workable. But yeah, the results are similar. Yeah.
Yeah, I would love to hear more from you on what this actually looks like, right? So in my head,
Yeah.
there's definitely some challenges here that maybe aren't as explicit to an architect as they might be to a structural engineer. So
There's another kind of cool concept called carbon cure, where they actually inject carbon into the concrete, and it's kind of the carbonation process. And these are kind of like an extra plant that goes in at the concrete plant, for the premix, that helps inject carbon into it, which is just kind of like another way to kind of stack on the benefits and make carbon a little lower, or sorry, make concrete a little bit lower impact. So one of the companies that's doing it locally is called Carbon Cure. I think they're based at the East Coast, but I believe they have a few add-ons to concrete plants in Ontario. I don't know, Mike, if you know that for sure. But
Yep.
that carbonation element is another way of, like, if we can just work at chipping away the impact of concrete, because we're always going to need it, we're always going to use it until we invent something totally new that can do all the things concrete can. We're going to keep using it, so let's just do as much as we can to reduce the impact of that. And Carbon Cure is doing, again, don't represent them, just think what they're doing is cool. Is another neat way of helping us get.
I
One
have
other thing.
actually I have
Go ahead, Manoj.
worked in. Oh, sorry. I have worked in similar kind of one where they inject microorganisms and they increase their strength. But they are also not cost efficient. It is more costlier than the actual method. Because they were doing for research purpose, and 4 5 criteria we casted and researched, but the results were either cost effective or not workable in most of the scenarios.
Yeah, and that's totally understandable. I mean, these things are always going to be more expensive when they're new, and we understand that, but we just have to hope that we've got clients that are interested in doing the right thing, that are interested in doing kind of the new thing. I mean, of course, it's not always going to work that way, we understand, but if you're not, if you're not part of the teams that are leading the charge, then you're part of the teams that are being left behind. So it's just up to us to try and always, push that envelope a little bit, because the more people get pushed, the further along we'll all get.
Manoj, because I feel like you're from a structural engineering background, so I'm also curious to hear your thoughts on things like, we had looked at glass powder, putting glass powder into the mix. We had looked at doing things like BFRP. Do you know BFRP? Instead
No,
of steel, right? As the
mhm.
reinforcement. So really kind of unique, interesting things. But inevitably, due to cost concerns, it's very challenging to integrate some of those pieces, right? So cost is
Glass
always
will
the.
makes glass
Go
will
ahead. Yes.
makes certain improvement, because similarly we introduced glass wool, and it also redefined certain structural property as well, but none of them are as per concrete, but introducing glass wool into the concrete were providing a similar result, which was almost equal to the actual scenario.
Yeah.
Mhm.
So did you like it, or maybe I missed it? You liked it though. The glass is
It
good.
was good,
Yeah.
because I'm surrounded by engineers, and my mom was researching on glass wool, and even there is a concept called CFST, where steel tubes are outer cased and concrete is being poured. In high-rise buildings, if we are going above 20 floors or 25 floors, it was meeting the cost as well, and structurally also it was providing much more stability, but floors which are below 20 floors, it wasn't matching the cost. Safest buildings are cost efficient if more than 20 floors or 1200 meter cube or cubic meter. I'm not sure of the numbers. Yeah.
Super fun stuff. So I'm always going to advocate to use natural materials. So mass
Mhm.
timber where we can, concrete where we can't, right? So because it is part of that carbon storage part, right? So that carbon
Mhm.
sequestration. But I really appreciate the conversation around concrete because, as Brianne said, as you said, it's not going away. We use it lots of places, foundations mostly, right? Not a lot of wood
Yeah.
foundations in Toronto. So um, but that's great conversation. Happy to continue it at another time. But Manoj,
Yeah, for sure.
amazing stuff, my friend. Thank you so much.
Thank you.
Perfect. That was a nice headway to almost. If there are no other questions, perhaps we'll just do a final conclusion. And thanks to PMI-CP and SPAN-EA, it looks like we're all on time. So looks like the training is definitely helping us right away. So perhaps Ricardo, if you have some last comments to add, and then we'll pass on to Mike and Obada and Brienne.
Well, thank you very much. I thought indeed it was a very great exchange. Thank you for your time. Thank you for joining us. We appreciate if you can join our LinkedIn group. We can continue the conversation there, as well as if you're interested in signing up for the certification and you have questions, you may post them there as well. Feel free to reach out, connect with me on LinkedIn. Yeah, really appreciate it.
Thank you. And I forgot to say it earlier, but Dr. Adel had some last-minute cancellation due to some health issues, so we apologize for that. He did email us right before the presentation that he won't be able to make it. Obada, anything to share?
Well,
Hamza, this is Vivian. I want to thank all the speakers for this valuable event and for all the knowledge that you shared. And we look forward to receiving the decks so that all the engineers can really value this. And thank you very much for recording that as well.
Thank you, Vivian. Obada?
thank you, Hamza. Thank you, Vivian. Well, first of all, I would like to thank Hamza for arranging this. And I think it's a big opportunity for us, SPAN and PMI, to start our collaboration and conducting such kind of event over here. And I'd like to thank Ricardo for his insightful presentation. I'm happy that PMI, they have something a little bit with more focus on the construction industry and project management. And finally, thank you so much, Mike, for your presentation. It was very insightful and sorry, I think for me, I learned a lot of new stuff today about sustainability, and definitely we're looking for more to talk about this.
Wonderful. Happy to be here. Thank you so much for the invitation, Obada and Laloa. Thank you so much. And Brianne and I are happy to be a part of it and to a greener future and all that fun stuff. So thanks, guys.
Thanks for having us and thanks for your questions.
You're
Have a great
welcome.
day.
Loloa, do you want to say anything? I didn't get a chance to. Okay, perfect. Then we'll end the presentation. Thank you, everyone. Have a good weekend. And we appreciate everyone being here. Thank you.
Thank you, everyone. Bye.
Thanks, guys. Bye.
Thanks, everyone. Bye.
Thank you, Lola.